Hi guys, this is chapter 2 test review, and we're gonna go through this first part really quick because we've gone over it once. But if you weren't here, this whole chapter is on transformations, which are just moving these figures around a coordinate grid, so an x and y axis. And what we're focused on these first few chapters are congruent figures, and these are figures that are exactly the same size and shape, unlike similar shapes where they might be the same shape, but they're not necessarily the same size. So down here, we have two little triangles. We can see that they're not the same size. So it asks if they're congruent. We would say no, because they're different sizes. Then we come down here. The first type of movement that we talked about is translation. And translation is when we can move a figure left and right, up, down, but we're not rotating it or switching its sides or flipping it or anything like that. So A would be an example of a translation. Well, B would not be because it rotates. And then the next one is a reflection, and that's just a flip. So there's this line here, and it's going to flip over it. And one way I showed you how to do this is if we have the point up here, and let's say this went over 8 spots to the left, then we're just going to do the opposite here and go 8 spots to the right. And every point would be the same way. If it went left 4, then we're going to go right 4. And so that would be a reflection on the y-axis because y goes up and down. So this would be an example of a reflection. Over here, it would not be with these hearts. One way I could tell is if I have this line here and I'm going, let's say 4 up, then I should go 4 down and the bottom of the heart should be right here. So my heart should look something like that if it was a reflection. So the second one is no. Okay, so we're going to jump down to these problems, which is our test review. And the first one is translate. So that means we can go left, right, up, down. It says translate. Get this out of the way. Translate down 5 and left 7. So for each dot, so there's a dot right here for A, I'm going to go down 5. So 1, 2, 3, 4, 5, and left 7, it says. So 1, 2, 3, 4, 5, 6, 7. Here's my new dot right here. And that is A. So I'm going to put an A there with a little apostrophe, letting me know that that is my A. You're going to do that for every single dot. And then you're going to mark the points. So I'm not going to do the whole thing for you, so you can do some. So you do the same thing for C. You'd go down 5, left 7. But A, we just mark its point. Here's the origin right here. And I'm going back because I have to label my points. I'm going back 1, 2, 3, 4, 5. So a -5. And down 1, 2, 3. So I'm going down -3. And then you do that for all the other dots. That's translation. Reflection, there's 2 types that can go across the x-axis and across the y-axis. So the x-axis, we know that the line that goes horizontal is our x-axis. That means we're going to flip it on the other side up there. If it was a reflection on the y-axis, we'd flip it on the y line, which goes up and down. But I'll do 2 dots for you, and you can do the rest. Let's start with dot W. We want to reflect on the x-axis. So if I have my W right here, and I want to reflect it, I'm going to start on the x-axis. I'm going to line up with the W, and since it goes 2 down, I'm just going to go up 2. I'll put my new W here, and I'll mark my point, which is 1, 2, 3, 4, 5, 6, 7 back and 2 up. So it would be a -7, 2. And then let's say I want to do the Y. So I'm going to line up next to the Y. I'll put my cursor, my pencil on the x-axis, line up to the Y, and I go down 1, 2, 3, 4, 5. So instead, I'm going to go do the opposite, go back to the x-axis and go up 1, 2, 3, 4, 5. Mark Y with my apostrophe. I forgot the apostrophe down here. And then I would just mark that. So -2, up 5, we said. And I do that for the rest of them until I get my rectangle. Next is a rotation. And to do a rotation, the way I showed you to do it is, first of all, we have to know when it says 90 degrees, we have to know that every turn we do is going to be 90 degrees. So if I turn it one time, that's 90 degrees. If I were to turn it another time, that would be 180 total, because every time we're at 90, and then 270, and then back to normal would be 360. And then we also know, just like a clock goes right for clockwise, well, counterclockwise is, this is what it's asking for, it goes left. So this one says 90 degrees counterclockwise. So we're going to rotate this, our whole paper, we're going to turn our whole paper one time to the left. So what we want is the triangle that we have should be in that top left corner. And it's starting off in the top right. So what I'm going to do is I'm just going to write EFG here. And I'm going to label my points. I'm going to pretend and use my imagination that I didn't just flip my paper. And to do that, I have to say that up here is my Y. Over here is my X. So this would be my negative X and my negative Y. And I'm just going to plot those points using my imagination, like the paper hasn't been flipped. So G would be -1 up 2. So I'd put -1, +2. For my F, I will put, it's right here, I'll go back 1, 2, 3. So -3, 1, 2, 3, 4, 5. So -3, 5. And you do the same thing to E. I'm not going to do that just yet, so you can finish that. But we're going to take our paper, and we're going to, after we plot those three, we're going to flip it right side up. And then I'm just going to graph those points that I had. So point F would be -3, 1, 2, 3, up 5, would be right here. My apostrophe, point G would be -1, 2. So I go back 1, up 2, be right here. 2, 3, 4, 5. Oh, I got to bump this up 1. And then you would plot the other one. Then you'd connect your dots. Make sure that you label all these though, so you don't get confused on which dot is which. So this one is a G apostrophe. And then you would have put the third one on there to see where it would go. But remember, it should look like this when you're done. Should look like this in the top left corner. All right, next one, it says describe the transformation. From these ones, we just have to describe what's happening. So we talked about the different types. There's translation where the shape can move left and right. There is, or up and down. Go left, right, up, down. There is flipping, or reflection where it flips. So I could flip this up, down, or I could flip this left, right. Or the last one that we talked about is rotation. This one, I can see that it's going to be a reflection. The reason I know this is if I start on the line here above the C on the x-axis, I can see that I'm going up 1 to this C, and I'm also going, I can go down 1 here and have C be in line with it. A would be the same thing. I could go up 1, 2, 3, 4, and I go back to the other, start at the x-axis, and I go down 1, 2, 3, 4. So those are reflections. And I have to be specific, and it reflects on the x-axis. So I would just put reflection on x-axis. This one, I want to describe a transformation to see what's happening. I can tell that it's not going to be a reflection this time because the A's wouldn't line up, or else it would be here, and it looks something along those lines. So it can't be a translation because it flipped over, or I mean, it rotated. So it has to be a rotation. Remember, we are starting at the non-shaded one. I know this because there's no apostrophes here, and these ones have the apostrophes. So it's starting off in this triangle right here. So for this one, this is one where it's a little more, you can eyeball it and you can double check by on you by rotating your paper and seeing if it were to line up. You can turn it and then plot your points and then check if they line up with the other shape. And so this one would be an example of rotation. So there's two different types of rotations it could be. It could go around 3 whole times. And be in that location. Sorry about that. So you could rotate this 3 times. So I'm trying to cut this off so it's not as big as it is now. Here we go. So you could rotate this 3 times. So we're focused on this little red one, or on this little white one here. I could rotate it 1, 2, 3 times. And this white one's now in the place of that black one. That would be a rotation of 270 degrees. Or the fastest way there, starting back at normal, is I could rotate it 1 time to the left. Remember, left is counterclockwise. So your answer on this one would be rotation 270, or even better, rotation 90 degrees counterclockwise. This one is going to be the third type that we haven't used. Well, I can see it's not a reflection on either axis, or it would be over here or down here, something like this. So it's not a reflection. It's not going to be a rotation. The reason I can tell is because the triangles are both lined up the same way. They're both set up like this. So it didn't rotate. So the last one is just going to be a transition. So you just have to find one dot and line it up to the other one. So I'm going to do A. I start off at my A. I'm going to go from the white one to the dark one, and I just count how many it goes over. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the left, and 1, 2, 3, 4, 5, 6, 7. So it goes 10 units left and 7 units down. And I have to make sure that I know that it's a translation. So remember, translation is the one that slides. Then there's going to be some multiplication ones, not multiplication, I mean multiple choice ones, and you just have to choose the correct answer. So this one says, I have these two here, and I have to decide what it does. So did it rotate 180? Well, that sure could be a good possibility, because if I'm starting right here in the top right corner, if I rotate 180, it should be diagonal from it. But if I were to rotate this triangle, if I were to rotate this triangle, I can do this, cut it out pretty easy. On yours, you'd have to turn it and make your dots to be sure. But if I were to rotate this 180, so 90 180. I can see that it's not quite lined up the way it's supposed to be. So it can't be that one. So B, reflect across the x-axis, and then on the y-axis, I know that it would look like this, and then I flip it downward, I'd have something that looked like this, which is not going to be the same. So it can't be that one. And then translate 6 down and 6 left. It can't be that one because that would just be meaning it's going over and down, but this one did rotate. So process elimination, it has to be D. It rotated 90 degrees clockwise, counterclockwise, I mean. So remember, if we had our paper and we rotated it 90 degrees clockwise, it would look like this. Starting off here, I'm going 90 clockwise. Oops. Counterclockwise, I'm sorry. 90 degrees counterclockwise. And then reflect across the x-axis. So to reflect, I would just go, if C's 2 up, I'd go 2 down, and here's my C. B would be 2, 6 up, so I'd go 6 down. And I can already tell that this is the shape that it's making. So your answer would be D on that one. Number 2, this one, reflect across the y-axis. So Y would be this line over here. Look something like that, and then rotate 90 degrees. Well, if I rotated this 90 degrees clockwise, it would be back over here. So it couldn't be that option. Then reflect across the x-axis. So if I reflected across the x-axis and then reflected across the y-axis, so here would be my C, here would be my B. That one could work. So I go up 1 and there's C, and I go down 1, there's C. I go up 1, there's B, I go down 1 and there's B. Well, the drawing's a little off, but so on this one, it is going to be B. And then you're going to have these ones where it says, we have this figure here that A, B, C, D, and it translated 9 down and then rotated 90 degrees. So it did all the work already for you. It started off as this shape, and it went, each dot went down 9, or the whole thing moved down 9, and then it went clockwise to form this one. So what they want to know is which side is going to be the same as those ones down here. So if this one, let's try doing this again. If this one went down that many spots, went down 9 spots and then rotated. So just imagine starting here and it went down and then it rotated 90 degrees clockwise. Then the shape should look like this. They line up and I have to match the sides. So for example, side AB right here, or no, AD is the first one. AD would be the same one as this one down here. So AD would be N. AB over here, so here's AB or BA, doesn't matter which way the letters go. It would be this side right here, which is the same side O's on. And you just go through and do all 4 sides. Figure ABCD, which is this one right here, doesn't have the apostrophes, is transformed to make this figure. Select true or false. Figure ABCD has rotated 90 degrees counterclockwise. True or false? Well, it can't be that one because if it rotated, we're just doing true or false for these. If it rotated 90 degrees counterclockwise, it would be up in this quadrant right there, and it's not. So it can't be, that one has to be a false. Figure ABCD has rotated 180 degrees. Well, that one sure could be because it is over here. And we can check that one. So I will So we can check it. Sorry about that. We can check that one by rotating our paper. I just don't want to do this whole graph here. We'll just rotate the whole thing. So we want to rotate it. It said 180 degrees. Sorry about this, taking far longer than it should have. Forgot my keys for a second. So we're going to rotate this 180 degrees. So if I were to rotate this 1, 2 times, what I can see is, although it's in the same location, the problem is these letters aren't lined up. So AB should be on the bottom. It should be down here. This should be my A and B. And then that means that D and C should be up here. So the reason that one's false is because the letters don't line up. So the second one is also false. And then, that should mean the third one's true, but we'll check it. Figure ABCD has translated 6 units right and 10 units up. So here, we'll start off at B. We'll go 1, 2, 3, 4, 5, 6. And then, so we're trying to get to, and 10 units up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one is actually false because we want to go from B to B. And we went from A to A. So although it's 10 units up, to get to B, we have to come all the way up here to line up to B. So in this case, they are all false. And that is our review